Hello everyone, I want to welcome you for this lesson, and today we are going to look at the trapezium rule. What is the trapezium rule? The trapezium rule is a numerical technique that we use, majorly to find the value of integrals. We use it to find the value of what? Of integrals. We know very well that we also have some of the analytical method, or the method that we have in, you guys cover in paper 1, pure mathematics, that is estimating the area under the curve, bounded by x-axis. This is x-axis, this is the line x equals a, that's the line x equals b. So we can use integration as an application to find the area of that, which is equal to the integral from a to b of f of x dx. Now, sometimes we have some functions which are very complex, and then we may not use the direct method. It will be so bulky, and therefore we now employ the numerical method techniques in order to find the value of that integral. There is a formula that we use, the formula for the numerical method. This formula we're going to look at is given by the area under this curve is half h into the first value and the last value yn, then plus now have twice times the middle value y1 plus y2 plus y3 and so on and so forth. So this formula in blue is what we call the trapezium rule formula, and majorly it helps us to estimate or to find an approximate value of the area under the curve. Okay, so we have that formula. Okay. Now, how do you apply the trapezium rule formula in order to get the values of your integrals? For example, we can have an example 1 that is applying the formula of trapezium rule in order to find the area under the curve. The curve must be bounded by the y-axis, by the x-axis, and then the x values from x equals a and x equals 2. So let's look at this example that use trapezium rule. With 5 ordinates. To find the value of an integral from let's say from 0 up to, let's say, 1 of the function f of x. So our function can be, let's use this, 1 over 1 plus x dx. Correct your answer, correct to, let's see, 3 decimal places. So we got the expression that we are supposed to use trapezium rule with 5 coordinates in order to find the value of integral from 0 up to 1 of 1 over 1 plus x with respect to x. And the degree of accuracy is already given. We need to correct our answer to 3 decimal places. Therefore, as a student who has already learned trapezium rule, what do? We know very well that there are some words that we need to understand. For example, the word ordinates and vis-a-vis the word streets. So these two words tend to confuse students. So when you say 5 streets and then 5 ordinates, what does it entail? When you talk about 5 streets and 5 ordinates, I'm very sure your teacher must have told you the difference between streets and ordinates. The number of ordinates exceed the number of streets by 1, and therefore if we have 5 ordinates, then we mean the number of streets is 4. So we will have that as our solution. We first need to get the width h of the strips that we have formed using trapezium rule, and the formula is the upper limit minus the lower limit of the integral divided by the number of strips. So this n is the number of strips, not the number of ordinates. So if the equation gives you the number of ordinates, we need to subtract 1 to get the number of strips. So this is the layout of our work. So my h, which is the width, what's the upper limit? The upper limit is 1. It's very clear there. 1. What's the lower limit? Is 0. So 1 minus 0 divided by n. We said earlier that n should be the number of strips, not the number of ordinates. So therefore, if we are being given ordinates like that one, we need to subtract 1. So 5 ordinates is how many strips? 4 strips. So that gives you the width of each strip must now be 1 over 4, which is also 0.25. So that one will be the width of the strip. Now, having gotten that width, we shall now have to draw a table where we have our x values and also the y values, the corresponding y values. Is that okay? So let's draw our table, and we shall have that kind of table clearly drawn. So the first column will take the value of x. The next column will have the first value, y naught, and since we are using 4 strips, so it will end up to 4, that's the last value will be 4. Therefore, this one will take the middle value, y1, y2, and y3. Since the last value is y4, we'll stop there at y3. Correct. So our first value is the first limit of the integral, which was 0, the lower limit. If you can, then you keep on adding the width 0.25 on that. So the next value of x is you add the width on 0.25, so we shall have 0.25 plus 0.25, which is 0.5. And then we shall keep on adding 0.25 on that, shall have 0.75, add 0.25, we have 1. So remember our integral, 1 is our upper limit, and therefore we shall now be stopping on the upper limit. Okay? Now, the corresponding value of y is obtained when you let y to be the function 1 over 1 plus x, that function that you're going to integrate. So what you do is that you get for each value of x, you substitute here, and then you get the value of y. So if x is 0, for example, that will give us the first value, which is y naught. You substitute it here, 0. So that we shall have 1 over 1 plus 0. Then we shall write that value there. So clearly we are going to have here to be 1. That's when x is 0. Now the next value is when x is 0.25, you substitute here 1 over 1 plus 0.25. So you get 1 over 1 plus 0.25, which is 1 over 1.25. Press your calculator and give us clearly the solution. So having written that, we shall obtain that value, write it here. These are what we call the middle values. These middle values, to write the values here corresponding. And finally, the last value, 1 over 1 plus 1, you get 0.25. So we shall not stop there. We shall now have to proceed such that we get the sum. We need to get the sum of our values. So 1 plus 0.25, we shall have to get, this is 0.5, that will be 0.5. So 0.5. So that will give us 1.5. Then we also need to get the sum and write it here. Now, having gotten those two sums, we now substitute back in the formula for trapezium rule. So let me extend the page a bit. Correct. Now, in our formula, we have the area, which is A, our area A, under that curve, which is given by the integral from 0 to 1 of 1 over 1 plus x dx Yes, it's now approximated by, we use the approximate because that is not the exact value. So we shall have to use the approximate. Write the formula, which is a half h, we wrote it earlier. H is the unit of speed, which we have gotten as 0.25. Then we multiply by the sum. This sum, the first one here is, the first and the last value is 1.5. Then plus twice this sum that we have gotten here, we add on it, we get that sum, then we multiply. We proceed with the working and then we write our answer. Remember, the degree of accuracy of our answer, the final is to 3 decimal places. So that we need to round off, but we need to round off what we have. So you press your calculator and write this value to many number of decimal places. For example, I can have 0.3829196. And later on now, we write our answer to the required number of decimal places, which is 3 decimal places. And we shall take that, and that. So 0.382 indicates 3 dBs. So friends, this is how to calculate numbers on trapezium. Thank you for watching.